just to make sure we're all on the same page here, the reason that domain is what it is because what we can't get is square root of negative numbers. And so the thing that's going to cause us to have square root of negative numbers is if this number here is too small, so that when we subtract 1, we get a negative number. So if the thing that we square, when we square it, we get something less than 1, then when I subtract 1, I'm going to get negative 1. So I can plug in things like negative 5. That's no problem. Negative 5 squared is a positive 25. Minus 1 is 24. And I can take the square root of 24. So I can get some negative numbers. As long as we're not between negative 1 and positive 1, then we should be fine. So that's going to be our domain. So that'll be important when we start to talk about our sign chart in just a second here. But let's go ahead and take our derivative. Derivative here is, derivative of square root here is going to be 1/2 times the thing to the negative 1/2. So that means it's going to go on the bottom. So that's our derivative with the square root. But then, of course, we need the chain rule and multiply by the derivative of the inside part. Derivative of x squared minus 1 is going to be 2x. So I'm going to go ahead and cancel these 2's and say that this is x on top. And then I have a square root of x squared minus 1 on the bottom. So we got f prime is 0. F prime does not exist. These are finding our critical points. Let's see, f prime equals 0. That is where the top is 0. So where x is 0, well, that's all we have for the top. Then on the bottom, f prime does not exist. Well, that's where the bottom is 0. So that's where the square root of x squared minus 1 equals 0. That's going to be 0 when the thing inside the square root is 0. And you can either add 1 and take plus or minus, or you can see that this is going to factor into x plus 1 times x minus 1. Either way, you should get x being plus or minus 1. X is positive 1 or x is negative 1. So now I'm going to make my sign chart. Negative 1, positive 1, and then I had 0. Guess what? 0 is not in our domain, so we don't care about it. So we don't need to deal with this zone at all because the function doesn't exist there. So we need to think about what's happening in the derivative to the left of negative 1, what's happening in the derivative to the right of 1. So it's saying if I plug in a negative number, so let's say I plug in negative 2, well, then I would get a negative 2 over, well, this bottom is going to be positive. Right? I got to get a positive down in the square root. So I got a negative over a positive. That's going to be negative. Then I have to the right of 1. So if I have a positive number, let's say I plug in like positive 3, then I have 3 over, this is going to be positive. So I have a positive over a positive, which is a positive. And you can plug in any number you like, and we're not interested in the number we get out. We're more interested in the sign. So here's negative, here's positive. So now that means that we are decreasing until we hit -1. Then we don't exist for a while. Then we hit +1 and start increasing again. So my hunch is that the function looks something like this. We are decreasing and decreasing, and then we hit -1, and then we're going to hit +1 and start increasing again. So that's what this is going to look like. So these are both, since we are getting to, we are decreasing to this point and then stopping, we are starting at this point and increasing, these are both minimum. These are both going to be a minimum. And they're going to be absolute minimum. So absolute min. Well, if I plug in -1 or if I plug in +1, now we're plugging into the original function. Plug in -1, well, -1 squared is 1 minus 1 is 0. Square root of 0 is 0. Plug in 1, I'm also going to get 0. So both of these kind of tails start at 1, 0, and then go off in their directions. All right, I'm going to jump down to part F. I'll jump down to part F, and then I'm going to let you try some problems on your own here. All right, and I'm actually going to yeah, let's do that. All right, we want to think about the domain first. So we want to think if there's anything I can plug into the bottom that's going to cause an issue. There's not. All real numbers. But let's look at our derivative and see what we get. This is going to be a quotient rule. We have low, d high, derivative of the top, that's going to be derivative of x is 1, minus high, d low, derivative of x squared is 2x. Over the square of what's below. So remember, we're looking for where is this derivative 0? Where does this derivative not exist? Square of what's below, sorry, squared here. Where does this derivative not exist? Well, it's where x squared plus 1 is 0. Well, x squared plus 1 is never going to be 0. We'd get square root of -1. That's not on our graph. So where's the top 0? Well, if I'm figuring out where the top is 0, it's going to help us to simplify. So when people are asking the question, how much do I need to simplify these problems? A lot of it is down to, well, what are you trying to do? I'm trying to figure out where this is 0. So I actually do want to get some work out here. So x squared plus 1 times 1, x squared plus 1, and then minus, I got a 2x squared, equals, I've got a negative x squared plus 1 over x squared plus 1 squared. So when does negative x squared plus 1 equals 0? Well, that's again going to be, if you solve this down, at x equals plus or minus 1. So now here's where we make our sign chart. Here is -1. Here is +1. So we want to plug something between -1 and +1 into our derivative. Let's pick 0. So we got 0 plus 1 over 0 plus 1. That's going to be positive. Well, the bottom is always going to be 0, so I don't need to worry about that. Because as soon as I take, no matter what's in here, I'm going to end up squaring it, so it's going to end up being positive. So really, I'm just looking at the top. If I have a negative number, so let's say I plug in -5, I take -5 and square it, that's going to be a positive, but there's a negative out in front. +1 isn't going to overcome how negative it is. Same if I plug in a +3, let's say. If I plug in a positive number to the right of 1, then I'm going to get something, a negative number that's bigger, +1 is still going to be negative. So we have a minimum at well, which one is going to be our minimum? Our minimum is where we're going to change from decreasing to increasing. If you can't keep them straight, then kind of sketch it out. A minimum should curve like this. So that means we need to change our slopes from being negative to being positive. And so -1 is our minimum. 1, where it changes from positive to negative, is going to be our maximum. -1 over -1 squared is +1 plus 1 is 2. So there's a -1/2, -1/2. And then here it's going to be +1/2. So questions on that one? Okay, I want you to try now. I want you to try part D, and I want you to try part E. So I'm going to give you about 10 minutes, and I want you to try these two problems on your own. While you're doing that, I have some new homework assignments for you. They're posted on the Canvas page. So if you go into modules here, you should see 2 book assignments posted there for you to get started working on. It's going to be asking you to solve these kind of problems with the first derivative and talk about what information the first derivative can tell you. So I'll give you a few minutes to get started on these two. Remember, you want to start by thinking about what the domain is of these functions. So on part E here, once we get this derivative of being 0 at 1, one of the groups asked here, so what do you do after this? So what we do after this is we're going to look at where the derivative is positive and negative. So we're looking at this function. Well, again, a square root has got to be positive. So we're really looking at where is this part 0. So I'm focusing on this part. And so I want to pick a point here between 1 and -1 to test. It doesn't really matter what point we choose. We could just as easily pick a really messy decimal as long as it's between 1 and -1. But to make it easier on ourselves, I'm going to pick 0. If I plug in 0 here, I'm going to get a 2 on the top, and then I'm going to get a 2 times the square root of 3 on the bottom. But all I care about is that it's positive. And then let's take a number between 1 and 3. Well, an easy number to pick between 1 and 3 would be 2. And I would get 2 minus 2 times 2 over 2 times the square root of a bunch of stuff that's going to end up being positive. So I'm going to have a negative on top over a positive, which is a negative. So this means we are increasing and then decreasing. So we're increasing between -1 and 1. We are decreasing between 1 and 3. So that means that 1, if we're changing from increasing to decreasing, oh, that makes this a maximum. And so our maximum, if I plug 1 in, or 1 into the original function, I'm going to get out 2. So that's going to be my maximum. My minimum, if I plug in -1 and 3 here into the original function, because that's going to be my smallest value. Since we have a closed interval, it's going to be like on Monday. I'm going to have my smallest value. I put in -1, I put in 3. On both of them, I get out 0. Hopefully that wasn't too hard to get, because that's where we got the endpoints of the domain anyways. So again, you have 2 homework assignments to do based on that.